All right, here we go. Last lesson for this particular skill. We're going to talk about the infinite geometric series. You'll need notebook paper for notes, scratch paper for checks for understanding problems, and scratch paper for IP problems that you'll do on a Google form. Let's start with the concept of geometric series and what it means to be infinite. So we've looked at finite ones where we were looking for like the nth term of a geometric series. So those are finite because we had an ending point. But a sequence could go on forever and thus having an infinite series. To find the sum of a series that's made up of a geometric sequence, we first want to see if the sums converge to a value or if they diverge. To do this, we're going to look at partial sums, and we're going to see if we notice a value that they approach. So I have two examples here. We're going to find the sum of each of them. The sum of this first one, let's confirm it's geometric. So we're going to look and see what the common ratio is. 1 times a half is a half. A half times a half is a fourth. A fourth times a half is an eighth. So our r is 1/2, and so we want to see if this converges. So partial sums, that means I'm going to add two terms at a time. So I'm going to take my 1 plus a half. I'm going to use the decimal version of a half. That gives me 1.5. So now I'm going to take that sum, so the 1 plus a half, and I'm going to add to that 1/4, which is 0.25. When I do that, I get 1.75. So the first three terms, that partial sum is 1.75. Now I'm going to take that sum of 1.75 and I'm going to add 1/8. 1/8 on our calculator, if I take 1 divided by 8, I get 0.125. If I add that to 1.75, I'm going to get 1.875. That's going to be the sum of the first four terms. Now we're going to take that 1.875 and let's add 1/16. 1 divided by 16 is 0.0625. If I add that to 1.875, we're going to get 1.9375. Let's see what we observe. Okay, so we had 1, 1.5, 1.75, 1.875, 1.9375. The drop-offs are getting smaller and smaller as we go from one sum to the next. So it seems to me, since we keep adding a value that's getting smaller and smaller, closer to 0, it looks like eventually we're going to be, if we go out to infinity, we're going to be thinking of adding virtually 0 to each term. So it looks like we are basically approaching 0, or approaching the value 2. So 1.9375, we're getting dangerously close to 2. So we're going to say this converges to 2. Notice that happened when we had r equals 1/2. For the next one, let's find out our common ratio. So we're multiplying by 2, r equals 2. If I find my partial sums, I have 1 plus 2, which is 3. I'm going to take that 3, I'm going to add the next number, which is 4, and we get 7. And if I take that 7 and I add the next number, we get 15. And if we look here, unlike what we saw before, our value that we keep adding to the previous partial sum is getting larger. So the sums are getting larger, and because they're getting larger and it doesn't look like they're approaching one single value, we're going to say this sequence, or the series rather, diverges. And that happened when r was equal to 2. Okay, so we're going to use these ideas to help us come up with a theorem. Our theorem says if we have this geometric series and it equals some s value, so if I'm saying that this series comes to a single value called s, we're saying that if this series converges, or or we're not saying if it converges, we're saying this series does converge if our R values, absolute value, is less than 1. And if it does converge, our sum is this formula. Now you'll notice this looks similar to the finite one, except we're missing that 1 minus r to the n piece that would normally go in the numerator. Well, if our r value is less than 1, r to the n, so think of that as like 1/2, for example, to the n. Well, when I take half of the previous value, and then I take half of that, and then half of that, and then half of that, this is approaching 0 as n is getting larger and larger. So then 1 minus basically nothing is 1. So then 1 times our a1 is just a1. That's where this formula comes from. But again, you don't really need to understand that right now. You'll just need to know when to use this. So we want to determine if each series converges or diverges. And if it converges, find its sum. So this first example, we're starting with n equals 0 to infinity. So we have to figure out our first term. So normally they call it a sub 1. In this case, the number we plug in is 0. So we're going to have negative 4/5 to the 0, which we know equals 1. R is this value here, so negative 4/5. If I take its absolute value, that is less than 1. So this is going to converge. Since it's less than 1, remember we said if the absolute value of r is less than 1, it converges. Otherwise, it diverges. So we can find a sum. Our sum is going to be our first term, so we found that to be just 1. So 1 over 1 minus negative 4/5. Add the opposite here, we get 1 over, let's see, we'll call this 5/5. So this is 1 over 9/5. So keep change flip. 5/9 will be our sum. And by the way, it makes sense here because this is a negative number. Our n value, every time n is odd, we get negative, and every time it's even, we get positive. So we're going to be alternating signs. So it makes sense that we're going to get a relatively small value. All right, if we try the next one, let's look here. So pi over 2, how does that compare to our less than 1 versus greater than 1? Pi is about 3.14. So if I divide that by 2, 3.14 divided by 2 is 1.57. Since the absolute value of r is greater than 1, so r being 1.57, since it's greater than 1, this series diverges and there will be no sum. Okay. For this third example, again, let's figure out our r. So the way to think about this, let's figure out our first term. So we're supposed to plug in 0, so really this is a sub 0, but in the formula it's like our a1. So it'll be 2 times 1/5 to the 0, which is just 2 times 1, so it's 2. Figure out the next term. That would be 2 times 1/5, which would be 2/5. Figure out our a2. We're going to take 2 times 1/5 to the second, which would be 2 over 25. It looks like we have this common 2 in common, so that's this 2. And then we're taking 1/5, so 1/5, 1/5. So 1/5 looks like our r. And since the absolute value of r is less than 1, we would say this converges. And since it converges, we can find a sum. Our first term was 2, so we're going to have 2 over 1 minus a fifth. So that 1 is the same as 5/5, so 5/5 minus 1/5, so we have 2 over 4/5, which is 2 times 5/4. So we get 10/4 as our sum. You could simplify that to 5/2 if you wanted. Alright, so for this, I don't have any actual whiteboard problems that we can do, but what I can have us do is I'll just give you an R value and you're going to tell me if it converges or diverges. So I want you to answer that when we do these problems. I'll make a multiple choice so that you just have to click them. Okay? Alright, now that you've had a chance to practice these problems, that's all that there is to this lesson. So you're going to complete the IP, you're going to submit it on the Google form, and you'll be finished with Skill 16. So have a wonderful day.